Right, everyone, we are now in part 2 of our discussion this week. For part 2, we are going to focus on expressing a quantity as a percentage of another. Here, we are going to find the percentage, the rate. Alright, for you to be able to understand, let's focus on this particular question. In a class, there are 8 boys and 12 girls. Question is, what percentage of the class are boys? So if we try to look at it, we're looking into the percentage of boys in reference to the entire class. So we are comparing how many boys there are in comparison with how many total students there are in the class. So question is, how many students are there all in all? There are 20. All right, so we're looking into what is the percentage of 8 boys out of 20 students in a class. So to find the percentage of 8 with respect or in relation to 20, first we can express it as a fraction first. So the question what percentage is the same as what fraction. Remember, we can convert fraction to percentages. So we express it as a fraction first. So 8 boys out of 20, 20 being our reference point. And remember, to convert it into a percentage, we just multiply 100%. Okay? So remember our strategy here, we can multiply 100 by 8, but to make it simpler, we can just divide ahead of time. So 120 divided, that would be 5 and 1, thus giving you 40%. So we say 40% of the entire class are boys. Alright? That is how to express quantity as a percentage of another. How about if the question is, what percentage of the class are girls? Pause this video and try to answer it on your own. Similarly, we can think of comparing girls that with the number of students in the class. So we know that there are 12 girls out of 20, and then we multiply by 100%. Simplifying ahead of time, giving us 60%. But if the second question is given, and you know already the first question, you could already find it without doing this process. You can just subtract 60 from 100, since both boys and girls constitutes or composes the entire class, which is 100%. That is if you know the answer to the previous question. But if B is another question, then this is the process that you're going to do. Now, analyze this one. What percentage of the girls are boys? Pause this video and try to write your answers. So here, we're looking into how many boys are there in comparison with the girls or with respect to the girls. So our bigger set, or not a bigger set, but here we are looking into how many boys are there with respect to the number of girls. Therefore, our total number is the number of girls. Alright? So when you try to answer percentage problems or questions, you have to understand what is the bigger set in comparison. So in this case, we're comparing the boys with the girls. So it's boys out of the number of girls, in other words. So the word is out of. So the boys out of the number of girls. So here there are 8 boys out of 12 girls. And making it to a percentage times 100%, simplifying ahead of time. So we get 200 over 3. Again, 200 over 3 is something that might not be easily understood. Convert it into mixed number. So we have 66 and 2/3%, or as a decimal, 66.67%. Now, between the three, I would rather prefer the mixed numbered form and the decimal form, though they are all the same. Okay? Let's have another example. In a survey, 16 out of 25 people likes ice cream. So what percentage likes ice cream? So here we're looking into the number of people who likes ice cream out of the total people in the survey. So there are 16 people who likes ice cream, so that would be 16 out of 25, meaning out of how many are there in all. So converting it into percentage times 100, simplifying ahead of time, this gives us 64%. Alright? Now, how about the percentage of those who do not like ice cream? So if you know already the answer to letter A, B will just be its complement, meaning we can find the answer of B by subtracting 100 by 64 because the remaining percentage would be those who do not like ice cream, of course. That would be 36%. But if this is a separate question without knowing A, we can find it by looking into how many do not like it out of the total number of people. So here, there are 9 people who do not like ice cream out of 25. So converting it into a percentage, thus you get 36% as expected. Alright? Now, how about if the question is, what percentage of those who likes ice cream do not like ice cream? So here, we're looking into how many do not like ice cream out of those who likes. So the reference point here are those who likes ice cream. And we are looking into the percentage of those who do not like. Okay? So this would be those who do not like out of those who likes. And we know it's 9 out of 16. Alright? Converting it into a percentage, this would now be 225 over 4 or 56 and 1/4%. As a decimal, it's 56.25%. So it's really important for you to understand the problem and to know which quantity is the reference. It's out of who, out of what, because that will be the denominator. Okay? Now, going back to the concept of percentage increase or decrease, we could also apply the same thing. For example, the selling price of a product is 60. Its original price is 80. So find the rate of discount. So if you try to analyze this, the original price is 80, but then it is being sold at 60. So the price drops. Since it drops, therefore this is a percentage decrease. Alright? So how do we find the rate? First question, ask yourself, how much is the amount of decrease? Of course, you said that the price from 80 went down to 60. So how much is the amount of decrease, or how much is the discount? The discount is 20. Now, since it's 20, we can now find the rate of discount. So the rate of discount should be how much is the decrease, how much is the amount of decrease divided by the original. It should always be divided by the original price. So this will now be 20 out of 80, convert it into a percentage, simplify, this gives us 25%. So we say the rate of discount then is 25%. So the product is being sold at 25%. That's why from 80, it became 60. Now what if the question is, what percent of the original did you pay? What percent of the original did you pay? So here, we paid 60. The question now is, what percent of 80 is 60? So 80 is our reference point. It's out of 80. So 60, the amount you pay out of the original, which is 80. Therefore, 80 becomes our denominator. If you're not able to get that, you can pause and go back or replay this video. Alright? So it will now be 60 over 80, convert into a percentage, thus we got 75%. Alright? Next example. Due to VAT, prices have increased. A product which is originally 50 is now sold at 57%. Since the amount went up, so from 50, it became 57. So this is an example of a percentage increase. So how much is the increase in price? So the increase in price here obviously is 7. So to compute for the percentage increase, it will just be, so by the way, when you talk about percentage increase, some questions would call it markup rate. Markup rate is the price that the price by which it was changed to a higher amount. Or markup rate is the rate at which the price was increased by a certain amount. So this now becomes 7 out of the original 50. Take note, it should always be out of the original 50. So computing or changing it to a percentage, that would be 14%. Alright? What percentage of the original amount is the new price? So the question here, what percent of the original amount is the new price? So here, we are looking into out of the new price, out of the original amount, what is the percent of the new price? So here, it is in reference to the original amount still. So the new price is now 57 out of the original, which is 50. Okay, so in this question, the reference point is still the original amount. That's why we have 57 out of 50. Converting it to percentage, we got 114%. All right. Then we go to the last question. The price of gasoline decreased by 20%. The new price is now 48. What is the original price? So if we try to look at this, for you to easily understood this, let's say this is the original price, 100%, which we do not know. All right. However, we do know that there was a 20% decrease and you are only paying 80% because 20% of the price has been decreased. All right. That means out of 100, you're not paying the 20%. You're only paying the 80%. Based on the problem, what do you think is 80% of the original? So read the problem and try to analyze. Do you know how much is 80% of the original? Very good. 80% of the original is actually the new price, the one that you are paying. Remember, we don't know what 100% is. We know that we are given a discount of 20%. That means you are only to pay the remaining 80%. Thus, we know 80% is 48. All right? So how do we find the original price? We can find it by means of analogy or analysis. 80% of the original price is equal to 48. That is what we know. Now, we can actually, we wanted to find the original price, right? So that means 100%. But we cannot directly go to 100 from 80. However, we can express 80 as 10%. And from 10%, we can move to 100%. So here, it involves strategy and analysis. So from 80% to make it 10%, we can just divide 80 by 8 to get the 10%. In other words, from 48, since 80% is equal to 48, from 48, we could also do the same thing. 48 divided by 8 equal to 6. Therefore, we say 10% of the original then is equal to 6. Okay? If you're not able to get it, you can go back or replay this video. Since now we know 10% is equal to 6, we can now move to, or we can now compute for the 100%. So from 10%, we can now go to 100% by multiplying it by 10. So 10 times 10 times 10% is 100%. Therefore, if 10% is equal to 6, 6 times 10 which is equal to 60. Hence, we say the original price is $60. So this is one way of analysis to find the original given the new price and the rate of decrease. Okay? Now, I'd like you to start either in red or yellow level questions, the worksheet. So you can find the worksheet, which is day 2, uploaded in ManageBack. However, in class, make sure to finish until green level questions. Further instructions will be given in class. Thank you very much, everyone.